Okay, children, please also tell me, is my screen visible to everyone? Children, is my
Yes, ma'am.
screen visible to everyone?
Yes, ma'am.
All right. So in the last class, now I completed with that lesson. Please put on your camera, everyone. Hafsa, Umema,
It's not visible for me.
Bidil's camera is on. Bidil, still I can't see your video.
Mom, your screen's not visible.
Is my screen not visible?
My camera is on.
Ma'am, you're
Yes, ma'am, visible.
Please tell me, is my screen not visible to everyone or just to Hafsa?
Ma'am, your screen is visible.
Visible, ma'am.
It's visible, right? Hafsa, child, please check your issue. I guess it's
Can
some
you
issue from your side then.
Can,
Okay, Umema, you turn on your camera.
Mom, can I rejoin?
Yeah, sure. Please rejoin quickly. Children, in the last class, I completed surface area and volume, right? So does anybody have any doubt in this chapter? Any doubts in this chapter? Any question that anyone wants to ask?
No, ma'am.
Tell me, children, I also told you to revise this chapter well because upcoming test will be on this lesson only. The first two exercises, surface area part, I've taken the test. Now the volume part, I will have to take the test. So revise the volume part well. Okay. Also, Bidel, why did you not attempt the test? Only Umema has attempted the test from this batch. Tell me, Bidel, why did you not attempt the test?
Ma'am, it was on last week, right?
Yeah.
I was having some burnt in the school and I come at late. I was having backup class the whole week.
Bidel, your voice is too low to me. Just yes, children. Bidel, I'm not able to hear you. Your voice is too low for me.
Ma'am, I was having backup classes and I was
Yes, children. So, the next chapter, children, did we complete quadrilaterals?
No, ma'am.
See now what all chapters are left. You guys. Heron's formula I have done. Surface area volumes done. Statistics is left. Yeah, these chapters are left. So children, from these three chapters, please tell me which chapter do you wish to start? What chapter is going on your school?
ma'am, next class onwards we'll be starting with quadrilaterals on school.
With quadrilateral. Okay, Anumema, you what
Ma'am,
about
we are
you?
doing circles right now. We have done quadrilaterals.
You've done quadrilaterals and then you're doing circles. Okay, and Abdullah? Abdullah, what about you?
Yes. Yes, ma'am. Yes, ma'am.
Abdullah, do you hear me?
Yes, yes, ma'am.
Children, I'm audible to everyone, right?
Yeah.
Abdullah, why are you not responding? Abdullah, put on your mic and speak.
Hello. You can hear me?
Yes.
Yes, ma'am.
Which chapter is going on in your school?
Ma'am, surface area and volume.
No response. Okay, children, so I will be
Surface area
starting
and
with
volume.
quadrilaterals. Yes, Abdullah?
Surface area and volume.
Abdullah, please speak loudly.
Ma'am, surface area and volume chapter.
Circles. Okay. Children, so let's do one thing. Let's first complete quadrilaterals and then we'll come to circles. Okay. So in today's class, I'll be starting with the chapter quadrilaterals. So first of all, who will define me what is a quadrilateral? Who will define what is a quadrilateral? Mama, why is your camera off? What do you understand by quadrilateral? Bidil, are you there?
Yes, ma'am.
Yes, Bidil. Tell me what you understand by quadrilateral.
Ma'am, quadrilaterals are the four-sided shapes.
Okay. So a four-sided polygon can be termed as a quadrilateral. That means if I have a polygon. Now what is a polygon? Polygon is a closed curve made of lines. A closed curve that is made up of lines is called a polygon. So a four-sided polygon is called a quadrilateral. Right, children? Now can you tell me what is the simplest polygon? Minimum number of sides that's possible for a polygon can be? Tell me, what can be the minimum number of sides possible?
10.
10. How come? I'm writing polygon, four-sided polygon is also there. So how come minimum is 10?
Oh no.
3.
3. Very good. 3 is the minimum side of a polygon. Right, children? So can you tell me now what is this polygon of 3 sides called?
Triangle.
Triangle. Very good. A triangle. Right, children? So a
Yes,
polygon
ma'am.
of 3 sides is called a triangle. Similarly, a polygon of 4 sides is called a quadrilateral. Okay, a polygon of 5 sides is called a polygon of 5 sides is called
Pentagon.
pentagon. Then hexagon, heptagon, and so on. Right, and octagon. So basically, in this chapter, we are studying a polygon. All the polygons that are having 4 sides. So all of them are called as quadrilaterals. So can you give me any example of quadrilaterals?
Trapezium.
Any example?
Ma'am,
Trapezium.
trapezium.
Okay. Okay. And
Square.
a square.
A
Rectangle.
triangle.
Very good. Rectangle. And
Parallelogram.
Rhombus.
Parallelogram.
very good. Parallelogram. Hafsa, you tell me one.
A rhombus.
Okay, a rhombus. Any other? Any other? We have one more. Can anybody tell me? What can be one more example? A kite. Right, children?
Yes, ma'am.
A kite is another example of a quadrilateral. Okay. So now I will just quickly recap. See, in 8th standard, we used to study about properties of all of these 6 quadrilaterals differently, and we used to solve questions on them. I will just recap all the properties for you once. So first of all, we have a square. So what is a square? When all 4 sides of the quadrilateral are equal. All 4 sides equal. So children, for any quadrilateral, you need to know about their sides, and you need to know about their diagonals, and you need to know one characteristic feature that is defining that quadrilateral. Why now I said 4 sides are equal? But if another student say, ma'am, this is a rhombus and it also has all 4 sides equal. So how will you classify that which is a rhombus and which is a square? This is a square and this is a rhombus. Both of them has all 4 sides equal. So how can you classify? What is that one defining feature? Can anyone tell me?
One angle is 90 degree.
One angle, no, not just one angle. In a square, all the angles are 90 degree. Okay, all the angles in a square are 90 degree. While in a rhombus, all angles are not necessarily 90 degree. So here you can write all angles 90 degree. Okay. What about a square? Now what about the diagonals of a square? The diagonals of a square are equal. Diagonals are equal. But what about diagonals of a rhombus? Diagonals are
They
not
are
equal.
parallel.
How come diagonals are parallel, Umema? What is the meaning of diagonals? These are diagonals. How come diagonals are parallel? Diagonals are not equal. Okay. For example, if one of the diagonal is 2 root 2, then the other diagonal is also 2 root 2. For a rhombus, that's not the case. Diagonals are not equal in length. They are of different lengths. Okay. Now, one more important feature for a rhombus is, for a rhombus, the diagonals bisect each other at 90 degree. Diagonals other at 90 degree. So for a square, or angles are 90 degree. For a rhombus, the diagonals are bisecting at 90 degree. Okay, just remember these things. The only common property for both of them is that all sides are equal. That is only the common property. So if I say all 4 sides are equal, so you will have 2 examples with you, square and rhombus. But if I tell you that define a square, like how is a square different from a rhombus? So now you have a lot of things to say. You have majorly 2 things, that ma'am, for a square all angles are 90 degree and diagonals are equal. While for a rhombus, diagonals are not equal, all angles are not equal to 90 degree. Instead, the diagonals are bisecting each other at 90 degree. Okay. Will you remember these points? Just write them down somewhere. Okay. Now, similarly, children, if I talk about a rectangle and a parallelogram, they also have one property equal. Opposite sides are equal. Both of them opposite sides are equal. But again, you have a similar kind of difference. Here all angles are 90 degree. Here all angles are not 90 degree. Okay. Remember this thing. Not what about the diagonals? The diagonals of rectangle are equal. The diagonals of parallelogram are not equal. Okay. Same thing. Same as a square and a rhombus. Okay, now but remember one thing, diagonals of a rhombus are bisecting each other at 90 degree. Diagonals of parallelogram are not bisecting each other at 90 degree. Okay, they are not bisecting at 90 degree. Remember this thing. very clearly. Then I'll just brief you about a trapezium and a kite as well. So what is a trapezium? What is the defining feature of a trapezium? That one very important point is one pair of opposite side is equal. Over here, children, I'm sorry, not equal, parallel. Please note this, parallel, parallel. Now, children, see, over here, this side is parallel to this side, while the other two sides may or may not be parallel, but at least one pair of opposite sides should be parallel. Okay, remember this very important thing. One pair of opposite sides is parallel in a case of trapezium. Okay, now, children, tell me one thing. If I draw a rectangle, can I say rectangle is a special trapezium? Can I say this? A rectangle is a special trapezium. Tell me, children. Can I say this?
Yes, ma'am.
Why? Why can I say this? Rectangle is a special trapezium. This is a true statement. But why is it true? See, I told you that for a trapezium, at least this property should be followed. Okay, that's it. So check that in a rectangle, is this property being followed? Do you have one pair of opposite side parallel? Yes. You have this pair of opposite side parallel. In addition to one pair, you have another pair as well in the rectangle. So in rectangle, you have additionally both the pairs are parallel. But the property for trapezium is being followed, right? So children, whenever this type of question will be asked, a square is a special kind of rectangle, rectangle is a special type of square, rectangle is a special type of trapezium, rectangle is a special type of parallelogram. Some of these statements are true, some of them are false. But how will you check which is true, which is false? Just check both the quadrilaterals, that rectangle is a special type of trapezium. That means look that for a rectangle to be trapezium, what property should it be following? Okay, what property should it be following? For example, children, I have a square and I have a rhombus. Can I say square is special type of rhombus? And I can say rhombus is special type of square. I have two sentences. Now, which of them is true? One of them is true, one of them is false. How? How will I check? Tell me, children. Okay, read the first statement. Read the first statement. Square is a special type of rhombus. Okay, that means I'm trying to prove that square is a rhombus. So check the property of rhombus. Right, I want to prove a square to be a rhombus, so I will check the property of rhombus. Now, tell me.
Ma'am, can you repeat your voice is loud?
Is my voice lagging? Rhombus, can you tell me any property of rhombus?
All angles are not 90 degree.
No, that is not the property of rhombus. I never said all angles are not 90 degrees a property of rhombus. I said all angles are 90 degree is a property of square. Yes, Vidal?
Ma'am, diagonals are perpendicular to each other.
Okay, good. Diagonals are perpendicular to each other. And children, opposite sides are equal. all sides are equal, opposite sides are parallel. Three properties I have, right? Now, Mema, why did I say that all angles are not 90 degree? That will not be counted as a featuring property. See, because look here. If I talk about a square, it can be a special type of rhombus where all angles are 90 degree. The defining feature are three. All sides are equal. Yes, all sides are equal. Opposite sides are parallel. Yes, opposite sides are parallel. Right? Then diagonals bisect at 90 degree. Yes, diagonals bisect at 90 degree. Three properties are being followed. Yes. So square is a special type of rhombus where all angles are 90 degree. But if I say rhombus is a special type of square, then it is false. Then it is false. Why can I not call a rhombus as a square? Because children, now you check the property for a square. For a figure to be square, importantly, all angles had to be 90 degree. The three properties were all angles had to be 90 degree, all sides are equal and opposite sides are parallel. Right? So rhombus is a special type of square, no false. Why? Because all sides are not equal to, all angles are not equal to 90 degree. Right? Children, are you understanding these true and false type of questions, how you will be answering? See, you will check the property of the quadrilateral first, the defining property. Okay, I'll give you a chart which has all the defining properties. Okay, you will learn that chart. You will just check all the defining properties if they are being followed, and only a very slight additional change is being made. Then the statement is true. That means it becomes a special case, right? So similarly, a rectangle is a special case of, tell me which figure. Rectangle is a special case of, children fill in the blanks.
Rhombus.
Not rhombus. Tell me which figure.
Parallelogram.
Parallelogram. Very good. Parallelogram. Good children. Okay. Remember it this way. Clear with a little bit of the concepts. Did you understand, children? A little bit about quadrilaterals. Now do you have knowledge? Abdullah, you're just sitting in the class. No response. No answer. Please remove your headphones. I'm not able to hear you. Look here, children. Now in your textbook, we have a few theorems with us. Now what is this first theorem? It says that in diagonals of parallelogram, children, write down the theorem along with me. Diagonals of a parallelogram divides it into two congruent triangles. Write down the theorem with me, children.
Then
Done? Okay, children. Now I will come to the proof. So look here. Look here, children. First of all, I will draw a parallelogram. Let's call this A, B, C, and D. Okay, now they are telling you to prove that the diagonal is. Umema, put on your camera. You have to prove that the diagonal
Ma'am,
is.
actually, when I'm turning on my camera, your voice is lagging and your camera is stuck. Yes.
Okay, and when your camera is off, then is it fine?
Yes, ma'am.
Okay. See, children, what happens that for a parallelogram, they're telling you that if you draw a diagonal, it's dividing it into two congruent triangles. So first of all, draw a diagonal. Let's suppose I draw a diagonal that's BD. So what is the construction? Just write down construction diagonal BD. Okay. Now what do you have to prove? To prove is, children, triangle ABD is congruent to triangle BCD. This is what you have to prove. Okay. Now we come to the proof. The proof. So look here, children, very carefully. If I have to prove that this triangle is congruent to this triangle, I will have to look for some angles and for some sides, right? I had various congruencies, like I had SSS, I had ASA, I had SAS, RHS, etc. So I will just try to look. Okay, see, what do I already know about a parallelogram? Okay, I know one thing for sure, that opposite sides are parallel. This side is parallel to this, and this side is parallel to this. I already know this. So what is given? Just write one sentence for given as well. Just write one sentence for given as well. Then my pen doesn't seem to work. It's given that AB parallel to CD and AD parallel to BC. Okay, this is given here. Now children, very carefully look here, that if AB is parallel to CD, then can I say that this angle is equal to this angle? Tell me, can I
Yes,
say that
ma'am.
this angle is equal to this particular angle? And
Yes,
if
ma'am.
AD is parallel to BC, then this angle is equal to this angle,
Yes,
right?
ma'am.
Can I say this? Why? What kind of angles do they become?
Alternate interior angles.
Alternate interior angles they become. So you can write this statement that angle, I'm just writing it here, children. Please make another point and write it. Angle ABD is equal to angle CDB. Okay. Then angle ADB is equal to angle CBD. Okay. Why? Because they are alternate interior angles. Just write the reason as well. And the third thing that I have is BD is common. So you'll write BD is equals to DB. That's a common side. And thus triangle ABD is congruent to triangle BCD. Okay, tell me by which congruency?
ASA.
ASA congruency, right? By ASA congruency. So children, if they are congruent to one another, so can I say that triangle ABD is congruent to triangle BCD? I can say this, and that was only asked in the question, that prove that triangle in the diagonal, there are two congruent triangles, right? So you got two congruent triangles, hence proof. Since this proof was easy,
Yes, ma'am.
then tell me what is the proof.
Yes, ma'am.
Yeah.
Done now.
Done.
The next theorem is now in a parallelogram. Opposite sides are equal. Now children, you have to prove that in a parallelogram opposite sides are equal. So what you will do is, from the previous theorem, I got to know that the triangles are congruent, right? That's what I got to know already. So from this proof only, can I say that AB is equal to CD and BC is equals to AD by CPCT? Tell me. The question is
Yes,
that
ma'am.
in a parallelogram, the opposite sides are equal. So from the previous theorem, I got to know, okay, that the two triangles I get, they're congruent. So for a congruent, I can apply CPCT and prove any of the corresponding sides are equal, right? So I can very easily say that AB side, this side is equal to this side, right? And then this side is equal to this side. I can say this, right? So what you will do is, if this theorem comes, you will do it. First of all, you'll write this whole proof. First of all, you'll prove them congruent, and then you'll write AB is equal to CD and AD is equals to BC by CPCT. Okay, children. Tell me you understand theorem number 2.
Yes, ma'am.
Yeah.
Okay. Yes, Hafsa, are you saying something?
I was just saying, yeah.
Please, Hafsa, repeat and speak a little loudly.
No, I was just saying, yeah, I understood it.
Okay, good. So now children, we come to theorem number 3, and theorem number 3 is a converse theorem. Now what are converse theorems? See, I'll just write a statement, read it very carefully. The statement says, if each pair of opposite sides of quadrilateral, if each pair of opposite sides of a quadrilateral are equal, then it is a parallelogram. So just read it very carefully. Now they are telling you the reverse thing. Initially they told you, if you have a parallelogram, opposite sides are equal. Now they are telling you, if you have a quadrilateral where opposite sides are equal, then it is a parallelogram. So you understand it. Initially they were telling you, you have a parallelogram, you prove it that opposite sides are equal. Now they are telling you, you have opposite sides equal, prove that it's a parallelogram. Right? So that these types of theorems are called converse theorems, which says the opposite of one another. Tell me, children, you understand this theorem? Now we come to the proof. See, if I have a parallelogram A, B, C, D. Right now it is not a parallelogram. What it is a quadrilateral which each pair of opposites is equal. So what I have is given this is equal to this and this is equal to this. Okay. Now children, what do I have is, to prove that this is a parallelogram. Okay, what was this one defining property of parallelogram? One was opposite sides are equal. What was the other? What was the other?
They are parallel.
They are parallel. Opposite sides are parallel as well. So if by anyhow I am able to prove that this side is parallel to this side and this side is parallel to this side. If by anyhow I'm able to prove this thing, then I can say that it is a parallelogram. So it's actually very easy. So then what I will do is I will draw a line, just do construction, diagonal BD. Okay, and now what is the proof? If I'm able to prove that this triangle is congruent to this triangle, so that's also again very easy. Okay, why? Because by SSS you clearly see this side is equal to this side, this side is equal to this side, and this side is common. Okay, so that's very easy now. So AB is equals to CD, and then AD is equals to BC. This was given, and BD is equals to DB, that is common. Okay, so what I have is I have triangle ABD is congruent to triangle BDC. Okay, by SSS. But now children, your question should be, ma'am, why did you prove them congruent? Our motive was not to prove them congruent. Our motive is to prove the sides parallel. So can anybody guess why did I prove them congruent? Can anybody guess?
Because when you prove it, it is congruent, then AC ABD will be equal to
Please speak
these.
loudly.
Ma'am, when you prove it congruent, then the like ABC, the angle ABD will be equal to angle BDC.
Very good.
Like
And so what happens if angles are equal?
alternate interior angles.
Very good. See children, what I have is I can say this angle is equal to this angle. Okay. Angle ABD is equal to angle BDC, and this angle ADB is equal to angle DBC. Okay. Why? By CPCT. And what you will write also, these are alternate interior angles. Okay. Thus, now children, when are alternate interior angles? Alternate interior angles only for a pair of parallel sides, right? Otherwise they are not parallel. If I don't, otherwise they are not equal. If you don't have parallel sides, then alternate interior angles are not supposed to be equal, right? So I know, now I'm able to prove that these were equal angles and these are alternate interior angles. Thus what you can say is AB is parallel to CD and AD is parallel to BC. Right children? Do you understand this part?
Yes, ma'am.
Okay, you all understood this? Only Umema is answering. Others did not understand. Abdullah,
Yes, ma'am.
you got it? Did you understand?
Yes.
Okay.
Yes,
Now
ma'am.
children, can you write the proof on your own? Quickly write the proof, write the theorem. And children, you should be having all theorems in your notebook. Okay. Write down theorem number
Okay.
1. Write down the theorem, write down the proof. Write down theorem number 2. In theorem number 2, you will write same as theorem 1. And then you will write this extra sentence. Then put the heading theorem number 3, write the theorem, write the proof. Children, are you done with the proof?
Yes, ma'am.
Everyone has completed?
Yes, ma'am.
Okay, so children, look here now. Now I come to the next proof. Now comes theorem number 4. 4, right? Now it says that in a parallelogram, opposite angles are equal. Right, children? Now this is again very easy proof. Why? Because again, what you will do is you will draw a parallelogram A, B, C, D. Just draw a triangle. Now you know very easily that how can you prove that this is a congruent triangle. Right, children? You can very easily prove that both of them are congruent.
Yes, ma'am.
ABD is congruent to BCD, right?
Yes, ma'am.
I've proved them many times now. And then what you will do is you can say that this triangle, this angle is equal to this angle, right? And then similarly, what you can do, you can draw another one, you can draw this one, and you can say this angle is equal to this angle. So you will have both the angles are equal. So very easy proof. You will first draw a parallelogram, prove the triangles are congruent, then just write that opposite angles are equal by CPCT. Another thing what you will do is you will write that when we change the diagonal, when I change the diagonal to AC, okay, with respect to diagonal AC, I will have angle B is equal to angle A. Okay. Done, children? Shall I come to theorem 5?
Yes, ma'am.
You
Yes,
can do
ma'am.
this proof at your as your homework, right? You will use which congruency? Tell me.
Yes,
Which congruency will you use? You can use any. You can use SSS also. You can use ASA also. Your wish.
okay.
The next is theorem 5 says if in a quadrilateral each pair of opposite sides is equal, then it is a parallel. Now they are telling you that if you will have each pair of opposite, please correct this. We already did this one. Just write side, just write angle. That means this is again converse theorems. Theorem 5 is converse of theorem 4. So what you will do is again what you have there is quadrilateral. Each pair of opposite angle is equal. So this is a parallelogram A, B, C and D. What is given to you in the question? This angle is equal to this angle. What is given? Angle A is equal to angle C and angle B is equal to angle D. Tell me, children, do you understand this?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. Now what you can do is, see, first of all, I can say very easily, I will first draw this diagonal, and then I will prove this triangle is congruent to this triangle by which congruency? You will have angle 1 second, children. Please just write down the theorem by the time. Just write down the theorem. Done? See now, children. We will not do it by congruency. Look here. Can I say this is angle 1, this is angle 2, this is angle 3, and this is angle 4? Okay. Can I say this? Now what did they give you? They gave you angle 1 is equals to angle 3 and angle 2 is equals to angle 4. That is what's given in the question. Now what is the angle sum property of a quadrilateral? Then what is the
All
angle sum
angles
property of a
are
quadrilateral?
360.
Sum of all angles is equal to 360 degrees. So can I say that angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 degree? Can I say this? Tell me.
Yes, ma'am.
Yes.
Now children, instead of angle 2, can I write angle 4?
Yes, ma'am.
See, angle 1 and angle 3 are equal. There's a little difference. So angle 1 plus angle 2. Angle 3, 2 and 4 are equal. So children, instead of angle 4, what I will do is I will write angle 2. Okay, and instead of angle 3, I will write angle 1. So instead of angle 3, I am writing angle 1. And instead of angle 4, I am writing angle 2. Equals to 360 degree. So twice of angle 1 plus twice of angle 2 is 360 degree. So
Yes,
2
ma'am.
outside the bracket, angle 1 plus angle 2 is equals to 360 degree. So angle 1 plus angle 2 is equals to 180 degree. Now children, angle 1 plus angle 2 comes out to be 180 degrees. So angle 1 and angle 2 are what kind of angles? They were co-interior angles. Co-interior angles. Right? And the sum of co-interior angles is equals to 180 degree only when sides are parallel. Right? So that's how AB comes out parallel to CD. Right? But now children, again, what I want is I want AD is also parallel to BC. So that is also easy to prove. What you will do is you will just take 2 and 3. Okay, you will just take angle 2 plus angle 3. So for that, what you will do is you will replace angle 1 with angle 3 and angle 4 with angle 2. Like this you can. Did you understand? See, I'll explain you again. What was given to me? What was given to me was that if in a quadrilateral you have each pair of opposite angle is equal, then it is a parallelogram. So this is a quadrilateral A, B, C, D. They're telling you angle 1 is equal to angle 3 and angle 2 is equals to angle 2 is equals to angle 4. Okay, this is given. Angle 1 was equal to angle 3 and angle 4 was equal to angle 2. Then what you did, you are applying angle sum property. Angle 1 plus angle 2 plus angle 3 plus angle 4 is 180 degree. So now children, what you want, initially I took this angle and this angle, so I will replace 4 and 3. So replace 4 and 3. 3 you will replace with 1 and 4 you will replace with 2 is 180 degree. Right children? And then you took twice of angle 1 plus angle 2 is equals to 360 degree, and then you got, I'm sorry children, 360, and so you got angle 1 plus angle 2 is 1, right? This was so. Yes children, done?
Yes, ma'am.
Understood?
Okay.
So children, now for this class, you will just keep it up